Hello everyone. Today we will solve another resultant problem. Here the problem states a 300-pound force acts horizontally to the right. A 400-pound force makes an angle of 140 degree measured clockwise with the 300-pound force. Find the resultant force geographically and algebraically. So let's visualize the problem. Here we have a 300-pound force acts horizontally to the right. So we will take a force rightward. This will be 300 pound. And then it says a 400-pound force makes an angle of 140 degree measured clockwise. So if we measure it clockwise, then it will go this way. This is roughly the 90-degree mark, so we will go beyond that. So let's assume this is the 140 degree. And this force will be 400 pound. So to solve that, we will have to find the magnitude of the resultant and the angle of it. So let's start. For resultant, we have a rule that's r square is equal f1 square plus f2 square plus 2 f1 plus f2, sorry, it will be 2 f1 into f2 cos alpha. So if we write here f1 is equal 300 pound and then f2 is equal 400 pound and then we have the alpha. Alpha is equal to the angle between two forces and that will be 140 degree. So if we do it one more time and remove the square from the r, which is our magnitude of the resultant, so we will have to root at both sides. So we will add a square root to the right and write the formula again. f1 square plus f2 square plus 2 f1 f2 cos alpha. And then we will put the values of f1, f2 and alpha. So let's start with f1. Here f1 is equal 300 square plus f2 square is equal 400 square plus 2 into f1, which is 300, and f2, which is 400, and then cos alpha. For alpha we will write 140 degree, and that's it. Now we will have to calculate it. So let's start. 300 square plus 400 square plus 2 into 300 into 400 cos 140 degree, and then we will square root it and we get 257.195. so we will round it up and then write 2. So this is the magnitude of the resultant. Now we will find the angle of it. Here the formula is tan theta is equal f2 sin alpha divided by f1 plus f2 cos alpha. And if we transfer the tan to the right, we will get theta is equal tan inverse f2 sin alpha f1 plus f2 cos alpha. Then we will go this side and put the values of f2, f1 and alpha. So we can write tan inverse into the value of f2 is 400 sin alpha. Alpha is 140 degree. Then we will write f1. F1 is 300 pound plus f2 400 cos 140 degree. So we can write theta is equal (400 sin 140) divided by 300 plus 400 cos 140 degree. Tan inverse, we get minus 88.57 degree. So the angle will be measured from the F1 or the first force that was introduced in this problem. So it will be from 300 pound and it will go anti-clockwise because we assumed the clockwise angle as positive. So the anti-clockwise angle, which is here, it's in the negative, so it will go against the clockwise movement, so it will go anti-clockwise. So the resultant will be this way, and here we can write the magnitude of it. And the angle between them will be and that's it. This is solved. Thanks for watching.